node, so obviously we need telecommunication network. And the hardware are the typical hardware that you will find in a telecommunication scenario. So you need your routers, your adapters, your sometimes you have dedicated lines depending on what kind of blockchain it is, or sometimes it can be done through Wi-Fi. Usually if you're a participant you can, but for the actual blockchain network, for the serious communication to take place, you need dedicated lines. Did we get a chance that day to see the servers they had in STPI, the Software Technology Park of India? We didn't, right? Okay. So, but it's basically anything that you typically have in a telecommunication network. And the challenges are the bandwidth limitations. So, this was something that I don't know if Mr. Pandey talked about yesterday, but when I had talked to him, he was talking about that also as an issue for the developers, because you really need fast speed. So a lot of this speeds is determined by the local government or the local companies that are providing it, and what those limitations are, and of course the cost. More bandwidth, faster speeds you need, more you have to pay. And how do you prevent distributed denial of service? Do we remember what DDoS is? So you overwhelm the server by sending fraudulent requests for transactions, and you send so many that the server gets totally nervous and shuts down. When I say nervous, we mean in the technological terms, but essentially it's the same thing. So then we are talking about the application layer. So all the apps here reside, things like smart contracts. So there is middleware that integrate blockchain with other systems that might be needed. For example, Chainlink provides decentralized oracles for real world data integration. So let's anybody understand what is an oracle in the context here? Not the oracle which can tell our future. It has to do with the blockchain may need for the transactions, or depending on what the purpose is, it may need external data, right? And that external data does not reside on the blockchain, it has to come from outside. So how do you form that connection so that whenever that external data is needed, it can be routed to blockchain? So usually it's called an oracle. Oracle simply means external data source. I don't know why they call it oracle, because it's very confusing, right? When you think of, when you see the word oracle, you think of something else. You don't think of external data sources. But that's what it is here in this context. And usually these oracles, like Chainlink is one of them, it allows blockchain and smart contracts to securely connect with some other external sources. For example, something as simple as getting the current temperature or current stock price. Maybe in the smart contract, an event is supposed to trigger if the stock price reaches a certain number. So that has to be monitored. So that's done through applications such as Chainlink. Is everybody getting a hang of what these oracles are all about, and why they might be needed as application, and why they reside on application layer? You have to give me yes or no or maybe. Okay, so let's redo this. So tell me what we know so far. We know that blockchain is there. Blockchain has to communicate with external data sources for certain things. Not all blockchains may need to do. So Bitcoin doesn't need to ask anything from external data sources, because it's all transaction based within the blockchain. But when we are talking about blockchains that are designed for business domains, especially which have smart contracts where something is supposed to happen once a triggering event takes place. So as an example, suppose a smart contract is written where it says that if the stock prices reaches X amount of rupees, then the CEO or whosoever, the software developer, has to get this much money, right? So how would the blockchain or the smart contract determine if the triggering event has taken place or not? You can't have somebody sitting there and telling it, okay, stock price reached, because it may be too late. Even a delay of a few hours or few seconds may mean loss of money. So usually these systems are automated. So when blockchain needs to be connected to these external data sources such as stock market pricing, right? So that is called as an oracle. Oracle simply means that blockchain has oracle, which is getting the external data. And one of the applications that is used is called Chainlink. So Chainlink is an application. It's not technically a part of the blockchain. It sits on top of the blockchain in that sense. That's why this is application layer. So all the things that are interacting with the blockchain but also interacting with the rest of the world, they all reside on the application layer. One example being Chainlink. How does that sound now? Is that better? So ask me like where is the gap in our understanding? Because if I don't know, I can't answer or help. Okay, hearing none, I shall move forward. User interface, right? Why do you think user interface is needed? Because we don't do well with abstract. Remember? There was a reason why Unix and those kind of systems did not become as popular as Windows or Apple. I mean, Apple beats everything else, because in Apples you don't need to do anything, right? It does it for you. So the interface supposedly is good. I'm totally biased against Apple, as you can make out, right? Are there Apple fans here? I'm sure there are. Yeah. Okay. I apologize in advance, but you'll hear me rant about Apple. I do this with my students because they show up in business classes, in tech classes, and then most of the time their computer is not working because Apple is useless, right? So then they're sitting there crying that, it's not working for me. I said, why did you buy Apple? Well, that's what everybody told me to buy. I said, why? Because that's what everybody is buying. But why? I mean, didn't you use your own brain to think about that your needs and what do you need, and therefore make the decision based on that? So see, human beings do this. We always we like to think we are making independent decisions, but most of the time, including me also, I'm not separate, we are unconsciously or consciously doing things based on what the rest of the world is doing. So sorry, even my students laugh at me because I talk so much about Apple. But it causes problem, it causes disruption in the class, because then I have to sit and explain to them how to take care of that problem, and then before we know it, 20 minutes are gone and so on. Okay, so the user interface is very key. Yesterday, Mr. Vinay was showing some of the ways. It's browser based, obviously. So easier the interface is, more likely that the participants who don't know much about blockchain and shouldn't know anything about blockchain, they should just be able to do whatever it is they need to do on the blockchain without having to know what's behind the scenes and what's in the black box. So that depends a lot on user interface. And yesterday when we looked at one of the slides where we were looking at what are the different disciplines that are involved in blockchain design and development and implementation, user interface is definitely one of those. So pretty much, a lot of things are needed for it to function well, and all of that is done through. So challenges: how do you design a user interface that helps the user and drives adoption? And of course, at the same time, because user interfaces are notorious for providing backdoors to the hackers who know how to exploit those loopholes, because it's like an app, right, sitting So, and this app, if it is not secure but is communicating with this very secure app, there might be ways to get into this very secure app also. It's like the Trojan horse. You remember that story? So if you are able to get into the Trojan horse, then you are able to get into the fort, even though the fort was very secure because nobody thought to look inside the Trojan horse. And of course, scalability is definitely an issue. It's not just for blockchain, actually, more and more with pretty much everything that these days, because the reason is more and more people are jumping into the digital realm. All of us are doing business using our mobiles, so that drives up the traffic, and then that's a scalability issue for most companies that they have to worry about. So that's our application layer. Any question on this? So here are some examples, very quick and very high level view, of course, but let's take a quick look. So we are familiar with Bitcoin as a blockchain, the original blockchain. So the hardware is all of this. I'm not going to go into the details of this because we'll forget after a minute anyways, right? And these slides will be there for you to refer to if you need to. Ethereum. So usually smart contracts, that's where most of the time Ethereum is used. And yesterday there was this discussion about transitioning from proof of work to proof of stake. Remember Mr. Pandey was talking about that. And of course IBM Food Trust, that's also permission blockchain. And so these are just some examples of blockchain that we kind of already know. So, any questions so far? What did we talk about? Let's do a quick review. I'm not going to move forward till I hear something. And maybe that's what you want. But what did we... Let's start with very simple. Based on at least the presentation I did, how many layers are there in the blockchain infrastructure? 5. What's the first one? Hardware. What does hardware consist of? What does it do?
The minimal requirements of the system that are performing as a node.
So the nodes and all of those things that go with it. Then second layer is data layer. What happens in the data layer? All the transactions, all the data, smart contracts, metadata, block, which consists of block header, hashes, and so on and so forth. That takes place here. What do we have next? Network, which basically is your telecommunication network. Then the what? Consensus mechanism. Did we skip that one?
Yes.
Oh, sorry about that. That's what I said. Why does that not sound familiar? Okay, let's go back. Oh, I did miss it. I'm sorry. I don't know what happened to that slide. Okay, let's go back. So consensus layer, I think we kind of know that's where all the algorithms and the network rules for the blockchain, not network is probably the wrong word because we may get confused with this one. But basically all the rules for the blockchain and how the consensus mechanism will take place, what are the incentives, all those things basically take place here. Somebody was asking a question, was it you who were asking me about, somebody was asking me about something about consensus. Anyway, so sorry that I don't know how I forgot, but that's okay, that happens. So all of that basically resides. So these are all softwares and algorithms and all of the things. So everything, all the coding here is related to how the consensus mechanism is going to drive this particular blockchain. If it is a consortium, it may have a blockchain that is using one type of consensus and another one that is using a different type of consensus. So all of that has to be there and then coordinated. Everybody good with that? Okay. Kind of very, very, very brief, but that's okay. All right, so let's go back to where we were. So, and then the last one was the application layer, right? Those were the 5 layers. So now we are going to take a look at something that Mr. Fazal was referring to, and then Mr. Pandey also referred to briefly. So can somebody tell me, based on what you heard from them, what is this blockchain trilemma? Acha. How many of you have taken a basic physics course? Okay, some of you. Quantum physics, I don't know if you guys read about it or not, but there is a principle which is famous principle called Heisenberg's principle. Have you heard about that? Yes, okay. So what is that Heisenberg principle about?
Momentum and position of a particle cannot be calculated simultaneously.
At the same time. So it's kind of a dilemma that in the quantum world, everything is about probabilities, right? So either you can say with certainty a particular subatomic particle is at this location, but then you wouldn't know what its speed that it's moving at. But if you determine the speed, then you don't know with certainty where it is located. So it's kind of abstract concept a little bit, but it's a very famous principle that is used a lot in other disciplines. In business, we always say, oh, you know, it's like Heisenberg's principle, that kind of thing. So it's a similar thing here. In Heisenberg's principle, we are talking about 2 things, the speed or the momentum and the location of subatomic particles. Here we have 3 things, so that's why it's called trilemma. And the 3 things are the decentralization, security, and scalability. The 3 of the 4, what was the 4th one? Transparency. So those 3 things cannot be achieved at the same time. And that is the dilemma. And that has to do with that if you try to make the system scalable, then the solutions that you come up with would impact decentralization or security. If you focus on security, that will cost you in terms of scalability. If you focus on decentralization, it will impact the scalability and maybe security. So that is basically an interaction of these 3 things. And achieving all 3 things simultaneously in a blockchain system, at least as of now, is not possible. So what you have is different solutions out there in the market, basically would focus on 1 or 2 of these while sacrificing the 3rd one, and therefore it depends on business domain to business domain, what it is you are comfortable sacrificing while achieving the other 2. If it solves your business problem with these 2, then yes, we are okay sacrificing this 3rd dimension. Now, there is a lot of research going on. There are a lot of people working on just figuring this out, that how do we solve this blockchain trilemma. So let's take a little bit closer look. So decentralization, we know that the distribution of control and decision making is across the blockchain network rather than in the hands of you. If you're talking about proof of stake, maybe that definition gets changed a little bit. Security, protection of data and transactions, and scalability. So we understand these 3 concepts. That's what this slide is about. Any questions on this? I think we are all comfortable at this point about these 3. Okay, so then everybody understand what the trilemma is then? It involves what 3 things? Okay. Can somebody tell me why having or give me an example of decentralization that impacts scalability? The Bitcoin, remember the number of transactions per minute is very, very slow compared to other traditional systems. It's like what, 7 or something? I can't remember that figure. I know some of you remember that very well. Kya tha? 7. Thank you. So that impacts the scalability, right? I mean, the number of transactions you can process in a completely decentralized system is very, very low. But if you increase the decentralization, if you increase the speed of transaction, that may impact decentralization. Did I say that correctly? If you increase the speed of transactions or scalability or make it more scalable, it may result in less decentralized. Are there systems we talked about, types of blockchain where this may be true? Like hybrid systems and even consortiums sometimes, the more blockchain networks you have talking to each other, more you are increasing the likelihood of security violations or less decentralization. But you are achieving scalability, you are achieving speeds. So a lot of these private and permissioned blockchains we were talking about earlier today and in the past also, like that Audio X, something about the music industry, I forget the name already, IPV and Ascribe and some of those. So they are closed systems because they are about a particular industry. They may be faster in how they process the transaction, but they may not be as secure or they may not be as decentralized. Everybody good with trilemma? If Mr. Vinay Pandey or Mr. Afzal asks you that, you'll be able to answer that question? Okay, so you get a chance to do that right now. You knew that was coming. Okay, so the first question is, what is the primary function of the blockchain's infrastructure layer? Okay. Everybody understand what that means? Okay, good. What is the role of network layer between nodes? What kind of communication typically takes place in a public chain? Right, but what is usually being communicated? So the block, every time a block is verified and new block is added, the blockchain is broadcast, or that is broadcast that, hey, here is the new version. That's one. And then the other is when miners are doing proof of work, the moment somebody finds the solution to that cryptographic puzzle, they broadcast that, hey, you know, I found the nonce and here is the nonce. Why is that being broadcast again to all nodes? For verification, because other people can check, okay, did this nonce really produce the hash that meets the network requirement of, let's say, 5 zeros? Because it has to be checked, right? I can't just say, oh yeah, I solved the puzzle, give me the prize. So it has to be verified. So those are some of the things that is part of the communication. So these are very simple, and as you can imagine, once we get into smart contracts and NFT royalties and those kind of things, there needs to be more messaging, more communication that needs to take place. So the complexity of the network layer would vary depending on what type of blockchain and what is its purpose. So which layer is responsible for storing the ledger? Data layer. That's easy. Okay, the application layer in blockchain, what is application layer being used for? So primary purpose is for the user or participant to interact with the blockchain application. Okay, I think I have, oh yeah, true and false. Is this true or is this false? Okay, so we know that we cannot achieve all three. If we achieve two, we are in pretty good condition or pretty good place, and trade off with the third one. But typically, most blockchains, at least the way it is now, you focus on one while compromising on the other two. Okay, so I think we talked about this already, but just very quickly. Blockchains struggle. Why do the public blockchains struggle and not private as much with scalability issue?
Because public is accessible to everyone and it is permissionless, but the private one is permission.
So what is the, which dimension of the trilemma is at work here? Decentralization. Very good. And usually low throughput and high latency simply means that the number of transactions being processed is low, and it's a long, there's a lag between when the transaction is entered, because it's once every 10 minutes, and that's set for a particular reason. But again, it can vary from blockchain to blockchain, and whether it's private, public, consortium, hybrid. The technical issues, oh yeah, this is where I think I had it somewhere in day one, but here it is repeated again, that Bitcoin, which is what type of blockchain? Public. You can see it's only 7 transactions per second, which is, you know, it's like people with the Munimji might be faster, right? But not as secure perhaps. Ethereum does much better, which is 30, but is that enough of a transaction speed if you are, let's say, doing supply chain management? Nope.
Solana does 17,000 transactions per second.
I'm sorry?
Solana.
Solana. So is that the blockchain that you're familiar with? And how does it do that?
मैम वो दोनों को यूज करता है POW और POS.
Acha. So it's a hybrid model. So it's probably, do you know which it is trading off from the trilemma? Decentralization probably, for sure, perhaps. So I'm not familiar with it, but the point is that if you are getting faster speeds, then something else is big. क्या चीज?
Solana claim रहता है achieve कर चुका है.
Trilemma, oh okay. That's, has it been verified? That's the question. But like I said, you know, it is as of now, but things move very fast. Tomorrow some programmer or developer can announce that, you know, they have solved it, and maybe Solana has solved it. I don't know. But the point is that it is a hard problem to crack. And a lot of mathematics and besides these sciences, you also need the hardware and hardware also that is capable of executing these things. Visa credit card, that's 24,000 transactions per second, and that's probably the low end, right? So you can see the difference in scale here in terms of the transaction processing speed. So that gives you right away an idea of the limitation of blockchain and where it can be applied. If you have a business which relies on transactions that are on the scale of what Visa is doing, right now blockchain is not able to do it. However, what is beginning to happen is these offline, online type of hybrid models, so which we will look at briefly. Consensus bottleneck, obviously we have talked about this before, that proof of work is a bottleneck. I mean, it takes a while. Energy consumption, of course. It's not really a bottleneck, it's more of a cost. But it can be a bottleneck if so not only the cost, but you also need steady supply, consistent, reliable supply of energy. It shouldn't happen that it gets disrupted or there's a क्या बोलते थे उसको, you know, power cuts, but we used to call it something else. Huh? Power outage. It used to be called, I'm forgetting the word. When I was growing up, that used to be that certain areas would be shut down. Huh?
Power shedding.
Power shedding. कुछ और आएगा. Usually I think of these terms after the class is over. So what are some of the solutions to these trilemma problem and some of these problems we talked about in the previous slide. So again, we are going to take a very high level view of these. So there is something called layer 2. I think yesterday there was, or Mr. Afzal's talk, he mentioned something about layer 2. So what is it? That's what we want to understand. What is it? So this is where it's called also lightning network. And the reason it's called lightning network is because it says, okay, now your processing speeds become lightning fast. And the solution is a hybrid, offline, online. So instead of having everything be done on the blockchain, the idea is you take advantage of the speeds of the traditional systems and then only put things on the blockchain that are in its final shape. So for example, let's say a bank is doing all the transactions every day. So instead of having each transaction be done on the blockchain, the idea is that you process those transactions the way they are processed in a very fast, perhaps using Visa or whatever it is mechanisms you have. Then at the end of the day, just like in the old days, the batch processing, you remember? Somebody will have a pile of papers and then they will put it in the Bahi Khata at the end of the day. Same concept here. So you do all these processing on the traditional systems that are really, really fast but not secure and definitely not decentralized, but they are very fast. At the end of the day, then you do whatever is the final tally of from all these transactions. So instead of putting all the transactions, there might have been 1 million transactions that day, but you don't have to put all those million because you only put the final unique one. So maybe these million transactions were about 1500 different customers. So you transfer the state of their balance or UTXOs of these 1500 customers onto the blockchain, and then that is secure. So then the next day you start the cycle. I'm just giving that next day. It may be every hour, it may be every 10 hours or whatever the thing you decide. So that's the idea of a layer 2 solution. So you have 2 layers, that's where that comes from. And it's called lightning network. So you may hear layer 2 solution or lightning network, that's what it refers to. So that's one. Everybody get a hang of what layer 2 is?
But in the meantime, when the data is, before the data is getting transferred to the blockchain, it's in an unsecured area. So hacker might get into that and it can be manipulated or anything can happen during that period of time.
Yep, so you're basically sacrificing security, you're trading off security. So there are these conversations about how do you make this offline thing also very secure, but because if we could make this offline thing very secure to begin with, we wouldn't need blockchain to begin with, right? The reason we need blockchain is because these traditional systems are not as secure. We talked about in detail yesterday about all those cybersecurity issues, right? So, but the idea here is that if something is hacked, it's only that, let's say, day's work, because whatever you had before that, that's already immutable on the blockchain the previous day. So if anything is happening, so you need to have systems in place where you can catch if there is any bad actor is doing something in those transactions during that day. So at least you should be able to catch that before that goes over to the blockchain. So there are all of these kind of considerations. But yeah, you are sacrificing security, but you're gaining speeds, which otherwise would not be possible. So layer 2 scaling, that is what it is called. That's one. The other one is called sharding. You might have used the glass shards, right? When you break the glass, you get all those shards. So again, don't ask me who came up with that name sharding, but that's the name they came up with. An idea here is that you break the blockchain network into smaller parts for parallel processing. It sounds very easy, but technologically it's fairly complex and computationally and cost-wise, but it is a solution for, so rather than blockchain trying to handle the whole block of chain that it has developed so far and so many new transactions all at the same time, you just let smaller ones do parallel processing, and then at the end of the day you combine the final result and put it back together again, because you still need one unbroken blockchain so you can go back in time. It's kind of like having the final ledger. So think of it this way, you have the head Munimji and that head Munimji, instead of doing the work herself, she has then decided, okay, she'll hire 10 Munims, sub-Munims who are going to do different ledgers, but at the end of the day, head Munim, she has to reconcile and make sure she has the final master ledger. And not surprisingly, in parallel processing, master-slave configuration is what is used. Interestingly, we can't use the word master-slave anymore because of connotations. So, you know, so I don't know what the terminology used now, but the idea is the same. There is one head honcho, and then you have people working, nodes working, or computers working on it. Okay. I spent 6 years on my PhD thesis, so it's kind of ingrained in my brain on master-slave configuration. So about 5-6 years ago, I was reading a blog, and they were talking, we shouldn't be using the word master-slave configuration in parallel processing because it brings up memories. And I'm thinking you should be spending your time in actually eliminating the slavery rather than talking about this, but that's okay. So, do we know layer 2 scaling and sharding? Can somebody tell me what problem are we trying to solve here with these solutions? Is it decentralization? Is it security, or is it scalability? Scalability. So all of these, scalability is the big thing for businesses. They want to be able to do more and more and more and faster and less cost. And then of course there are other, these are not the only two solutions being proposed right now in the market. There are many others, but these are the two main ones. A lot of companies are coming out with solutions based off these, and there's a lot of research also that is going on in computer science and mathematics about how to enable this and make it better, coming up with better algorithms. So this is where I think yesterday Mr. Vinay was talking about it, that Ethereum was facing the congestion problem due to scalability. So then they transitioned to proof of stake instead of proof of work. Once again, does somebody remember or can remind us about what is proof of stake? So more your holdings are, more the say you have in the validation process or consensus basis, as opposed to proof of work. Proof of work, everybody is truly democratic. You have only one vote. But in proof of stake, higher your holdings, more the votes you have. It's like the electoral system in United States right now. So, okay. The other thing that is a good benefit is lower energy use. All of these solutions, because you're using offline and so on, so not as energy intensive as just pure blockchain. So let's do a quick discussion. I think we can answer that, but let me not assume that we can answer that. Let me hear some thoughts on why scalability is a critical concern. Arey, I was assuming that you knew this already, and I'm glad I asked the question. Because most companies have to deal with a lot of transactions every day. I mean, how many companies you'll find which is doing only 7 transactions per second? Very few, right? Sorry? Increasing, yeah, that would be the solution. But the question I was asking is, why is that a concern? Because most businesses do transactions that are exceeding the 7 transactions per second limitation that we have on the public blockchain. Public blockchain has, you can say that it has how many of the trilemma? Public blockchain, does it meet all 3 of the trilemma? If not, which one it does not? scalability, because 7 transactions per second is really bad. So, okay. Second question has to do with how does the layer 2 solutions balance scalability with security and decentralization. I think I have another. Let me go to the next slide, which talks a little bit more about layer 2 scaling. So, layer 1 is the base blockchain protocol, and layer 2 is the third party protocol built on top to integrate with the base layer to make things faster. Where do you think the layer 2 protocol resides on our infrastructure layers? Where do you think the layer 2 would reside in our blockchain infrastructure layers we just looked at 15 minutes ago? Probably application layer, right? That's where all of those things would go. This is used to enhance efficiency, scalability, and speed. How? This is what it's talking about, how it's doing that. So, instead of recording every transaction directly on the blockchain, you off-chain these transactions and only interact with blockchain for final settlement. Kind of that head munshi and her hired hands who are doing this processing in the layer 2. So, the sub munshis are the layer 2, head munshi, she is the base layer 1 blockchain protocol. So, once they finish the processing, they give it to the head munshi, which is the base blockchain protocol, for validation and uploading, and once it is on the blockchain, what happens to it? It becomes immutable, right? So, it's there and it becomes part of the permanent record. Everybody good with what layer 1, layer 2 is?
One of the features of blockchain was there was no intermediaries involved. Adding layer 2 a third party protocol, won't it be adding an intermediary?
Yep. So, it's all about compromises. That's what we are talking about. The basic premise or basic philosophy that Satoshi Nakamoto came up with was total decentralization and total security, but it was not scalable. So, when you are talking about business applications, either you don't use blockchain or you figure out solutions that will give you the scalability even if you have to end up sacrificing because of the trilemma problem. Right now, there isn't any hardware, software, application, network, and consensus mechanism that gives us all three at the same time. So, yes, it is, you can think of it as how most IS applications work in real world, right? Most of them, they have to work with the old legacy system, but at the same time you hope you get some benefits from these new systems. So, yeah, that's the reality. Everybody good with what the two layers are? Yeah? Okay. So, this is a little bit more. I'm not going to go into the minute details here, but basically it is designed for making Bitcoin which is public blockchain, to enable faster and cheaper transaction by creating an off-chain payment mechanism. So, you can call it hybrid, they call it layer 2 or lightning network. Everybody good with the terminology here? So, there are different so, this basically is going back to that Alice and Bob example. So, you have the blockchain and you open a communication with this offline thing, do the thing, and then bring it back to the is it layer 1 or layer 2, the blockchain protocol? Base blockchain, layer 1. So, in the off-chain, Alice and Bob can conduct multiple transactions. Which time period, that depends on the protocol. It could be 1 hour, it could be 1 day, or it could be 1 month. But basically, you're doing your multiple transactions, and then So these transactions are taking place just like the regular, and then you close the channel when it is time to bring it from the layer 2 back to the layer 1, which is the blockchain protocol. So there is, so what do you think is the overhead here? Communication overhead, right? So and usually you have a lot of different channels. So it's kind of like you have this blockchain, and then it's got all these arms going out in different directions, where all these different offline transactions are taking place, and then they are bringing it back. So closing the channel, opening the channel is the terminology. Are we feeling okay about it? Okay. Then advantages, of course. That's why this is becoming the big thing. If you go and search on the Google about, tell me about blockchain, the second or third or fourth link would be something about layer 2 or lightning networks, because it's becoming very popular. And it's becoming popular because of these advantages. The scalability, do we understand why it is scalable compared to the pure layer 1 blockchain? Yeah? Yes? No? Maybe? Okay. And look at the number of transactions now. Compared to what we had before was 7. Now we are in the millions. So that's huge scalability. So even if you have to give up on what you were talking about, third party, loss of decentralization, loss of some security, it is worth it to companies to still be able to have best of both the worlds, right? So you still have your blockchain that is secured, whatever is already on it is still secure, but you still are able to do these transactions offline. So lower cost, faster, enhanced privacy, because this is, remember we were talking about when you go to the bank, only the bank knows who I am, right? But I can't know who the other customers are. But in a public blockchain, you know how many participants are there, what kind of transactions have happened from this public key or that private key, etc. You may not know who they are because they are still anonymous, but at least you can figure out. And then it enables small transactions, which is not possible in the Bitcoin because, again, of the transaction speeds. Everybody good with this? Okay. So, of course, there are challenges. Nothing is without the challenges. What are the challenges of using this two-layer solution or lightning network solution or layer 2 solution? So, channel liquidity, if you're opening a channel for the offline, how do you make sure that double spending problem is not occurring there? You remember what the double spending problem was? In blockchain, that is what it is designed for, to prevent double spending, because at any time you know who has how many funds. In the off channel, this is just like the regular thing. So you may or may not know that if the other person you're transacting with, do they have sufficient funds or not. Technological complexity, which, what happened to, sometimes it dies out, that's okay. It's back again. Routing complexity, and then partial decentralization. We were talking about the trilemma, so we are losing some centralization or decentralization, and we are also losing some security here. It requires lot more technical expertise because it's much more complex systems to set up and manage and maintain, right? Anytime you have hardware and software, there'll always be bugs, so somebody needs to be on call to fix the problems. So more complexity you have, more maintenance and expertise you require. And then, of course, when you're opening these channels and the same problems, you are conducting the business and the other person's network goes away, then you're stuck. Okay, so this is where Lightning Network is being used. Not surprisingly, micropayments. Can you think of places where micropayments are used a lot? Hanji? In the rural areas, very much. Yep. Biometric, yeah. So in rural areas, small businesses, royalties and those kind of things, right? Royalties are not always like 1,000 rupees or million rupees. Sometimes they can be 1 rupee or 50 paisa for every transaction. So in a way they are micro payments. So having to do that on the blockchain every time that's a new transaction would be very cumbersome. So a lot of these might be done on off chain. Retail payments, because retail things that we buy, they're usually not in very high amounts, right? Even if you're buying something, it's no more a few thousand rupees, which compared to the big transaction is still a small potatoes. And of course, gaming and streaming, I understand is, I'm not a gamer, but people do micro payments there of small amounts, I'm assuming. Okay, so the things, so this is the traditional blockchain, layer 1, and this is the Lightning Network with the 2 layers. So you can see the difference in speeds, the fees, the scalability, privacy, and then of course there are use cases. Usually these things are for larger transactions, but it opens up a whole new world. But again, keep the trilemma in mind. If you're gaining something, you're giving up or trading off on something else. Let's talk about sharding. So this is a partitioning. I think those of you, we had a gentleman here, I don't know, I don't see him here today. He was talking about RDMS databases. In databases, partitioning is a technique, very common technique to, speed up the transactions in the database. So it's the same kind of deal to improve scalability and efficiency. So what you do is you split the blockchain into smaller, more manageable pieces called shards, and then each shard or the small portion of the blockchain is doing its own transactions and its own smart contracts. So basically what you're doing is parallel processing. So it reduces the load and hopefully speeds up. So everybody good with so it's almost, you're adding other layers also, but it's not called layer 2, because layer 2 is offline, online type of thing. When we say offline, it doesn't mean off digital, it's just that it's not on blockchain. Here everything is still a blockchain, it's just you break the big blockchain into smaller pieces. Now this is not trivial also, it's not like, oh okay, let's just cut it every 10 blocks and so on. There is a algorithm and a lot of complexity involved in how do you break the chains and who gets what pieces and so on and so forth. But do we understand the basic concept of sharding and lightning too? Okay. So scalability issue solution, that's what the problem it is solving. Both of these solutions are solving the problem of scalability. And the definition is, it's a subset of blockchain network with its own data and processing capability. So it's kind of like you have these mini blockchains, they're all connected to the master blockchain. And each operates semi-independently, handling a fraction of the networks. So we have to think about, okay, are the new transactions coming to the master blockchain or are they coming directly to the shards? So all of these are considerations that can impact the speeds and the transaction and scalability. And there may be different instances where one is better than the other in terms of methodology. So, so they call it beacon chain, the main one. It's not called master, it's called beacon chain, which I think is a nice name. It's like those beacon on the lighthouses. And then or it's also called the main chain, and then you have shards. And the purpose of the beacon chain or the main blockchain is to coordinate the shards and ensure consensus and security across the network. So the transaction flow is that when a new transaction comes, based on whatever protocol and rules are put in place, it's sent to a particular shard. That shard processes the transaction. And then if it requires transaction information from another shard because that particular information about the owner's previous transaction is on another shard, then there's this communication that needs to take place. So there's a lot of message passing back and forth between the beacon and the shard and among the shards, right? So again, for me it's helpful to think of this head munshi and the sub munshis. Now we'll call them shards. So shard munshis. So they are talking among themselves. कि आपके लेजर में इसका नाम है, उसने क्या किया था पिछली बार, that type of thing. And then you're checking with the head munshi कि जी ये हो गया, ये इसको करें ना करें, that kind of thing. Exactly the same thing, but all in digital world. And then each shard, so this is something interesting. Each shard can have its own consensus process, which means that one shard could be working on proof of work, another could theoretically be doing proof of stake or something else. Again, depending on what kind of transactions, how the shards are divided or created, and what would be most efficient. So if you have a business that has types of transaction that can benefit from proof of work and also some part that can benefit from proof of stake, then that's how you want to divide it up. So it gives you a lot more flexibility, right? And then these are the other mechanisms that we haven't talked about, and we won't, because like I said the other day, there are so many of these consensus mechanisms that our heads would spin if we were trying to understand all of that in 15 minutes. Okay, so everybody getting a hang of sharding? Okay, so one more on this, actually two more. So one is the solutions advantages. So not surprisingly, scalability. Do we see how it is helping with scalability? Okay, resource efficiency, and then decentralization. It's still, so compared to layer 2 solution, which one is more decentralized? Sharding is more decentralized, and this of course depends, right? But the claim is that it's more energy efficient. And there's another, so what are the challenges, right? How do you synchronize the transactions across the shard? Because ultimately at the end of the day, you need to have a blockchain that has everything in it, right? So how do you enable that? How do you do that communication? How often, and so on? So that's a big deal. And different companies and different algorithms, they all have their pros and cons, So if you were a developer or if you were an adopter, those are the kinds of things that you would be asking questions about. Security risk is if a shard is compromised, and of course it can disrupt. So again, out of that trilemma, we gained on scalability, but decentralization is slightly less than a pure blockchain, and security is slightly less than a pure blockchain. Increased complexity. Why? Because you have to first divide up the work, coordinate the work, the messaging, and make sure that the network doesn't get overwhelmed and the messages are being answered, and all of that is very complex thing. And so if you have, instead of one, so here the network layer becomes critical out of all the infrastructure, because there's more load on the network now, more messaging, more things that are trying to communicate with each other, more the network has to be more robust with higher speeds and higher bandwidth. So these are some of the use cases. As you can see, these things are too small to read, and it was by purpose, because my main purpose in this slide was just to give you a sense of that it's happening a lot, as you can see from some of these names of the different systems. So I'm not going to get into the details of these. You'll have the slides later today so you can take a look. But the idea is that it's not a theoretical thing at all. Both Lightning network or layer 2 solution and the sharding solutions are being used. And remind me, did either of the two gentlemen mention sharding? For some reason I seem to remember. No? They didn't. Okay. All right. So, we are coming up to close. We are at the right place. So this one is giving a quick summary. Any questions based on this? Which one has higher scalability? Sharding. Which one do you think has more security? You need to secure each shard. The messaging between nodes, which one is more intensive? Sharding. And of course, I'm not sure the resource needs are low for sharding necessarily. It's just maybe lower than the Lightning 2, but it's more than the pure blockchain or beacon blockchain alone. Okay. So let's see. How about we take a minute to think about? I think we kind of talked about this, but let's have a thoughtful answer to this question. Feel free to talk amongst yourselves. Let me hear the buzz. Okay, I think I gave a minute. Is a minute over? Anyone? So the answer, yes, go ahead. Is it okay? He was I don't know who raised your hand first, but okay. How about you answer and then I'll come to you because he had his hand up before. Is that okay? Okay, go ahead.
Ma'am, lower transaction cost, scalability, faster transactions.
How? Why? How does it do it? That's the advantages.
By moving some of the transactions off chain.
Okay.
By layer 2.
And what is layer 2? Okay, so she had you are on the right track. So let me go to her because she's ek to zor se diaphragm off chain transaction. Okay, so and what are off chain transactions? Just very quickly. Okay, somebody else. So you're on the right track, off-chain transaction, which is the layer 2. So let's hear about what's off-chain transaction.
Ma'am, not off-chain transaction, but I was talking about lower fees. So there will be lower fees in the transaction because the initial and the final transaction which would occur, only that will be like on the transaction fees needs to be paid only on that.
So basically what you're doing is you have layer 1, which is your base blockchain. You open channels to the offline. When we say offline, it simply means off blockchain line. It's still online, it's still digital, it's still networked. And you create those channels where these channels are transacting with each other. So if I'm Alice, I open a channel with Bob and I do all my transactions. Then at the end of the day or whatever the time frame, only the final transaction is being uploaded to the Lightning Network, which is the base layer or the layer 1 or the beacon blockchain. Okay, so you were on the right track, but basically offline simply means opening a channel and then closing that channel and then doing the final transaction only. So that improves the scalability because what it allowed you, most of the transaction, if there were 1 million transaction, maybe 0.9 million transaction took place offline and then only the final last How much is 1% of million? 10,000? 10,000. So only 10,000 solutions. My math has become really bad over the years, I'm noticing. I used to be able to do this like that. Okay. So thank you. That was a good question. Let's do another one. The same thing about sharding. How does sharding in blockchain address the problem of scalability in trilemma? So it creates new smaller blockchains called shards, and then these smaller blockchains and shards are able to handle their own processing. So you're doing parallel processing instead of one blockchain doing one transaction at a time. Remember, each transaction requires proof of work or consensus mechanism, right? So now instead of this one consensus mechanism taking place, you have multiple consensus mechanisms, which is where the bottleneck is in blockchain transaction speeds. The consensus mechanism is slow. So you have them taking place in parallel in multiple shards, and that's how you're able to speed up the system and get better scalability. Thank you. That was good. You guys are really great at these questions. And then this is the last one, and then I think we are stopping because I see people are okay. So what are the challenges associated with these solutions? In Lightning Network, you are opening channels, right? What might be the issue? Security, bandwidth issues, telecommunication problems multiply, right? Anytime you're doing, and security and all of those. So opening and closing the channel and all of that you have to do. Any other? So security problems and so on. What about sharding? Oops, I went. What about sharding? Lot more communication has to take place. The nodes need to be able to communicate, and opening these shards is not always as easy as it sounds. Parallel processing may require some more resources, costly, and so on and so forth. Okay, so if we were asked what are the scalability issue solutions in blockchain currently, would we be able to answer those? Okay, that's all I needed to hear.
One problem for block, multiple nodes. What best it can be possible two nodes give same solution for the same time?
So, okay, what you're talking about collision problem. So you have to build that into the. It's the same problem even in the blockchain. If two transactions are validated independently, then how do you do? So either the timestamp, whichever was the first one. But in the sharding, you may have to set those rules in the telecommunication network or messaging network to prevent the collision, because that's in parallel processing that could be an issue, that if 2 or 3 nodes arrive at a solution. The idea therefore should be that they are working on different problems or different transactions to begin with. So then, the probability of them coming up with an answer to the same problem is not there, because they're working on different problems to begin with, or different set of transactions. And if the two shards are sending the message to, what is the name for the main blockchain? Beacon blockchain, then there has to be that protocol with the timestamp, whichever was, if they both came exactly at the same instant, which the probability is very low, then there needs to be a rule based on which one would be handled first. Yeah. Any other question? All right, so thank you again for being here and engaging in the day 4. I loved it. I don't know if you learned something or not. I hope so. So thank you again. It's always nice to have an audience and students who are engaged and can answer as quickly as you guys do. So, and then I think Professor Sahu is here for the next part, do they get a break or something, or? Okay.
We appreciate